Alright, so this is 8-2, solving exponential equations. So yesterday we did the graphing, now we're just going to be solving them. Your homework is in your packet. It's numbers 9, 11, 13, 21, 24, and 26. So 8-2, right here. And our learning target is I can solve exponential equations and inequalities. We'll be doing both. But the biggest thing to know, so here's some key concept stuff. The biggest thing you need to know is that these numbers right here, the big numbers, need to be the same anytime we're working with anything. So I'm going to zoom in a little bit. But you need to have the same base number. So we'll call that base, the same bases. Right? So you have 2x equals 8 to the third. We can't do really anything with the 2. It's prime, you can't break it down. The thing that's nice about the 8 is that it's a perfect cube. 2 times 2 times 2 equals 8. So my next step here is just rewriting this first part to say 2 to the third to the third. 2 to the third to the third, you can basically shift this a little bit and make this into now 2 to the ninth, right? Power to a power, we multiply. So we have 2x equals 2 to the ninth. Once you have the same bases, you can now equal the exponents, and you get that x equals 9. You could do that step from here, and you just have 3 times 2x, or x equals 3 times 3. It's up to you. I suggest simplifying as much first and then bringing it down. That's exactly what this is just saying. Right? You need the same bases, and then you can say x equals y. The exponents equal each other. I'll show you a little bit more difficult of a problem. We have 9 to the 2x minus 1 equals 3 to the 6x. So again, we need the same bases. I'm going to try to see if I can find a 3. And I notice, 9's a perfect square. 3 squared. So I have 3 squared to the 2x minus 1 equals 3 to the 6x. Again, you can simplify this first. I'm going to show you the other way now. But you would just use the exponents right here. So this is 2 times 2x minus 1 equals 6x. And now it's like a regular equation. We distribute. You have 4x minus 2 equals 6x. Subtract 4x on both sides. Bring the work up here now. So I have negative 2 equals 2x. And divide by 2, and I get x equals negative 1. That's really the gist of solving the equations. The biggest thing is knowing that you need the same bases before you can go to this step. You need the same bases before you can go to this step. Right, so that's kind of part 1. Part 2 is about compound interest. This is where we're going to get a lot of our real world examples, and it goes off of this right there. This formula tells us everything, and it seems like a lot, but it's not that bad. So our P is just the principal amount you're investing. R is the interest rate. N is the number of compounded periods each year. And T is the amount of time. T years. For example, an invest account pays 4.2% annual interest compounded monthly. If $2,500 is invested in the account, what will the balance be after 15 years? So I'm just going to write down the original equation, original formula, like that. All right. My P is right here. My rate is right there. My T is there. And then it tells me it's compounded monthly. So this is kind of like my N. What is the number? Now we just have to tell you how many number of them are in a year. So A is what we're looking for. My principal, we said, was 2,500. The 1 plus the R. Now, it's 4.2%. We need this in decimal form. So 4.2% is 0.042. So we have 0.042 on top over n. Now it says compounded monthly, so this is where it can get a little bit tricky, but it's going to be 12. Why 12? How many months are in a year? N is the number of compounding periods each year. If it says monthly, you know that n has to be 12. And then you have 12, that's n, times t, which is 15. Now here is basically where you're just using your calculator. You keep the 2500 on the outside, you have the 1 plus. You're going to do this problem first. So you're going to put in your calculator 0.042 divided by 12. You should get 0.0035, sorry about that. 0.0035 to the, and then you could do this little part right here, 12 times 15 is 180. From this point, you can work on a little bit more of simplifying. You just have 1.0035 to the 180, right? 1 plus 0.0035 is just 1.0035. This is now where we have to use exponents first before we multiply. So 1.0035 to 100 to the 180th power is just 1.8756. And when you multiply that with 2,500, you get 4,688.87. So after 15 years, if you initially invest $2,005 of your money, after 15 years with this interest rate compounded monthly in your bank account, is $4,688 now. This is kind of how interests work. If you do the stocks, if you do a retirement account, this is how that kind of works. Flip the page then. Our third concept is solving inequality functions and equations like this. So inequalities we're going to do, it's the same idea, it's just now we have an inequality. Again, our first step is we need to get the same basis. All right. Now before, it was easy because we just were like, okay, we have to find 3. We can't really get to 8 from here. But we can get to 2 from both of them. Right? 8 we can break down into 2 cubed. Keep the inequality. And the other one we can break down is 2 to the 4th, right? 2 to the 4th is just 16. And then you have the 2x minus 3 on top. Now that we have the same basis, we can take the exponents, distribute, and solve. So I add 12 over, I have 8x is less than 15, divide by 8, and I have 8x is less than 15 over 8. That's your answer for that one. If we wanted to put it on a number line, right here's 0, here's 15 over 8, it's an open circle, and it's going left, and it's less than. You could also test 0. Is 0 less than 15 over 8? Yes, it's true, so we're going left. For the second one, we have 2x plus 2 is greater than 1 over 32. This is our first time dealing with fractions. How are we going to deal with fractions? Left side's fine. Right, 2 is what we're going to probably shoot for. It's the 1 over 32 we're going to have to deal with. So 1 over 32, I'm just doing a little side work. This, you can always convert. Anytime you have a 1 over a number, is the same thing as saying 32 to the negative first power. All right. Once we do that, now we can break down 32 into 2 to the 5th, to the first power. Now you see where I'm going here. And I know that this is 2 to the negative 5th then. I can bring this back here now for this next step. I have 2x plus 2 is greater than 2 to the negative 5th. Now that they have the same bases, we have x plus 2 is greater than negative 5. minus 2 on both sides. We have x is greater than negative 7. Again, if we wanted to do a number line, here's 0, here negative 7. Is 0 greater than negative 7? True. We just make our arrow that way. Not crazy, just, take it easy, take it slow. I do want to show you one last example, and it's one of the more difficult ones with inequalities, and it's number 28 on the bottom. So number 28 on the bottom is right there. You have two fractions on both sides. I'm just going to rewrite in the right corner to show you how it's done. So 28, you have 1 over 9 to the 3t plus 5 is greater than or equal to 1 over 243 to the t minus 6. So I'm going to show my work right here. 1 over 9, we talked about that. That's just the same thing as saying 9 to the negative first. 3t plus 5 is greater than or equal to 243 to the negative first to the t minus 6. Once we're here, let's break these both down. Let's shoot for, for 9, the only thing cool about that is it's a perfect square. It's going to be 3. Maybe there's something to that. So I'm going to break 9 down to 3 squared to the negative first, which is to 3t plus 5. That gets a little jumbled. Is greater than or equal to. And the thing that's cool about 243 is that 3 to the 5th power is 243 t minus 6. Now what I suggest before you bring this down, we want to multiply all these together. We have the same basis, so we have 2 times negative 1 times 3t plus 5 is greater than or equal to 5 times negative 1 times t minus 6. All right, we want to work left to right. So you have 2 times negative 1 is negative 2 times 3t plus 5 is greater than or equal to negative 5 times t minus 6. Right? And then we distribute, so you get negative 6t plus a negative 10 or minus 10 greater than or equal to negative 5t plus 30. Let's add 6t to the right side. So we add 6t to the right side. We have 1t plus 30 is less than or equal to negative 10. Minus 40 on both sides, or 30 on both sides, sorry about that. And you're going to get then t is less than or equal to negative 40. That would be your final answer. A couple things. If you added 5t from the right to the left, that's fine. Just make sure that when you divide by 1t at the end, you flip the sign, and you will get the same answer. Other than that, that's all I have for you. Your homework again is 9, 11, 13, 21, 24, and 26. Bye, y'all.